Hello students, so welcome back to the series. That's a question which we would have got today from limits. This question is based on which concept? Of course, that's the question I'm going to ask you, and when you would have tried to solve this, okay, so you would have realized, see, there's a type of question which you can solve with the help of log. This is a question which you can solve with the help of definite integration, but to convert it to definite integration you need to take log. So let's start. So we will say, okay, let L be the limit, let L be the limit of this limiting value of this expression as n goes to infinity. Okay, now taking ln both the sides, so what will we get? Ln of L is equal to, now see, since ln log or natural log, ln means natural log, log to the base c, but since log is a continuous function, so log and your limit can interchange their position. So what will happen? Limit as n approaches infinity will come out of the log sign, and log will go inside the limit, and then you will be having limit as n approaches infinity of 1 by n into n factorial by n raised to the power n. Okay, so I think all of you would have understood what I did. So of course I use the property of log which says log of x raised to the power n. So the power over the input of log, that will appear as product outside the log. Okay, so the power is 1 by n, so that appears as product outside the log. Now what? So see, now I will be just expanding n factorial here. तो यहाँ पे n फैक्टोरियल एक्सपैंड करेंगे, इट विल बी 1 into 2 into 3 into 4 till n here. So upon n, see you have n has product in denominator, so I'll be writing it under every number of n factorial of numerator. Okay, now using the characteristic property of log which says that if you have log of a into b into c, you can write it as log a plus log b plus log c. So this imply ln of L, how much is it? So limit as n approaches infinity 1 by n times ln of 1 by n plus ln of 2 by n plus dot 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 ln of n by n. Okay, isn't that? So now what? So now we can write it as limit as n approaches infinity 1 by n times in summation form ln of r by n, r goes from 1 to n. Now I will be comparing it with definite integral form, and what does it? See, standard form is, standard form for the limit as n approaches infinity 1 by n into summation of f of r by n as r goes from 1 to n is nothing but 0 to 1 f of x dx. See, what does I always say? See, what I always say that you replace 1 by n which is an infinitesimal limit because n approaches infinity, so 1 by n approaches 0 by dx. Okay, and wherever in f the function you have r by n, you will be replacing r by n by x here. Okay, so that's what we are going to do here. So we'll say, okay, ln of L is integral when whose limit goes from 0 to 1, and function is ln, and of course we have ln x dx here, and that's it. Okay, so just integrate, and integral of ln x is x ln x minus x, and that goes from 0 to 1. Now one more interesting thing is here, and what is it? See, when we solve definite integral, first we replace x, the variable of integral, by the upper limit minus times the lower limit. So when you put x is equal to 1, there is no problem because 1 into ln1 which is 0, so 0 minus 1. So let me do it. So therefore ln of L is, so it's minus 1. Okay, now when we put x as 0, so 0 into ln 0, first of all ln 0 is not defined, so as x approaches 0, so what do we have? 0 into ln 0, but what is log? As x approaches 0 from the right side, positive side, log 0 approaches minus infinity, so that's an indeterminate form. So okay, so can we write it answer directly? My answer is no. So what I will say, okay, let's again put the limit here. So what am I going to do? I'm saying, okay, x approaches 0 x ln x, and then it's minus 0, of course. Okay, so minus of minus 0. So now see, it's minus 1. Now we have to evaluate this limit. As I said, as x approaches 0, x into ln x is 0 into infinity form, which I'll be converting it to infinity by infinity form and then using L'Hospital rule. So what do we get? So it's minus 1 minus limit as x approaches 0, of course from the right side, plus ln x. So differentiate, so derivative of ln x is 1 by x minus 1 by x square, and that's nothing but 0. So minus 1 minus 0. So the limiting value is minus 1. So therefore ln of L is minus 1. So how much is L? So the limit is anti-log of minus 1, which is, since ln is natural log to the base e, so when you take it that side, it will be e raised to the power minus 1, which is 1 by e, bachcho. Okay, so that was a question which we can solve with the help of the integration, definite integration, and moreover we can convert it to that form only when we take log here, bachcho. Okay, so that was the question for today, bachcho.